In this video, we're going to take a look at what are called mixture problems. These are problems where we maybe have two different things that we're trying to mix together in a particular ratio to get a certain outcome, or maybe we have a different combination like with money or coins, and we know the total value of those things and we're trying to figure out how many of each thing make up that total. So let's dig right in. This first one says, how much pure acid should be mixed with 6 gallons of a 50% acid solution in order to get a 70% acid solution? Well, first of all, we need to recognize that if we're talking about a 50% acid solution, that means 50% of that mixture is acid, and the other 50% of that mixture is probably water, something like that. So let's take a look at how that's going to come into play here as we work our way through this, and especially when I have the right tool. All right. So the thing I like to do when I'm doing a problem like this is to just draw out some little buckets so I can kind of organize the information. You definitely don't have to do this, but it helps me to kind of visualize and think about what exactly is going on in the problem. So we got these two buckets, and we're going to mix those together, and that's going to give us this third bucket, which is our mixture that we want it to be in the right ratio. So the first one, it says pure acid. Well, pure acid means that we have 100% acid. There's nothing else mixed in there. So that one's this one right here. And we don't want to put our hand in that one. Yikes. We want to know how much of that should be mixed with the other thing. So I think that's probably going to be our variable. Let's hold on to that thought. This one is our 50% mixture, and it tells us that we've got 6 gallons of that we're working with. So 6 gallons of this 50% mixture. And we want to end up with a 70% mixture for our solution. So, well, what is it asking us to find? How much pure acid should be mixed? So that's telling us right here, this is the thing that we want to be our variable, because that's what we're looking for. That's what we're trying to solve for. Now, the 70% solution is going to be made up of the 6 gallons plus whatever is added right here, that X gallons. So the total gallons of our final 70% solution is going to be 6 plus X. Might be a total of 10 gallons or 40 gallons. Who knows how much we're going to end up with. Now, we're going to focus in on the amount of acid that's in each of these buckets. So the amount of acid that's in the 100% bucket is all of it. So it is 1x, or just x. We'll call it 1 because that's the 100% piece. Then the amount of acid that's in this one would be 50%. Well, 50% as a decimal is 0.5 times the 6 gallons. So this right here represents how much acid is in this particular bucket, this 6 gallons. Then I want to figure out how much is going to be here. Well, I've got 70%, so that's 0.7. Oops. So that's 0.7. Let me back up a sec here. There we are. And we have back to the right tool. 0.7 times this amount right here, which is 6 plus X. All right. So each of these is going to give us the amount of acid that's in that particular version of our solution. So then let's solve. I think we can solve that equation. So let's go over here. And this right here, 1x is just going to be x, right? Then we've got 0.5 times 6. Well, half of 6 is 3. So x plus 3 equals, we have to distribute that 0.7 through there. So let's do that. So this is going to be 4.2, and then plus 0.7 times x, so we have 0.7x. All right, then we've got x's on both sides, so let's deal with that. We're going to subtract 0.7x from both sides, minus 0.7x. That's going to give us, remember this is 1 minus 0.7 would be 0.3x plus 3, and that's equal to 4.2. Then get that x by itself, so minus 3, we end up with 0.3x equals 4.2 minus 3 gives us 1.2. And finally, we're going to divide by 0.3 on both sides, and we end up with x equals 4. Now, what is that? X, remember, was the amount of the 100% solution. So that means in order to get the 70% out with the 6 gallons of 50%, we're going to mix in 4 gallons of the 100% solution. And our total solution that we end up with at the end is going to be 10 gallons of the 70% solution. All right, let's take a look at this second one. So for the second one, we have a garage sale, and they made some money, $390 with $10 and $20 bills. Okay, so what do we know? It says if there were 3 more $10 bills than $20 bills, find the number of each denomination. So I'm going to start by organizing that information. So we've got $10 bills and we've got $20 bills. Okay, we don't know how many of either one, but it does tell us there's 3 more 10s than there are 20s. So let's call the number of 20s x, and let's call then the number of 10s, well, it's 3 more than the 20s. So that's going to be x plus 3. Okay, so this is how many of each of those types of bills that we have. Now, similar to what we did in the one above, where we focused in on the amount of acid, in this problem, we're going to focus in on the value of each of those bills. So a $10 bill, of course, is worth 10 bucks, $20. So to get the value of those total bills, because that's what we're going to need, because we know the total amount of our dollar bills that we're working with, we have to multiply those. So we're going to take 10 is the value, right, times x plus 3. That's how many of those we have. So this is the total value of the $10 bills we have, plus 20 times x. This piece right here is the total value of those $20 bills. So if we had 3 of them, it's 20 times 3. If we had 40 of them, 20 times 40. Okay, and now we know the total value is right there, $390. I apologize for my yawns, my goodness. Okay, then we're going to go ahead and distribute and solve. So take that 10 through there. We end up with 10x. 10 times 3 is 30. So we have 30 plus 20x equals 390. All right. Then we got some like terms, I think maybe. Yep, some x stuff. So there's 10x and 20x would be 30x. And then we've got the 30 there still. So plus 30 equals 390. Then subtract 30. We have 30x. Holy cow, lots of 30s in there. Equals 390 minus 30 gives us 360. Divide by 30. And we end up with x equals 12. Now, what does that mean? Well, if x is 12, that means we have 12 $20 bills. So there's 12 of those. How many $10 bills does that mean we have? Well, put in 12 for X right here. So 12 plus 3, that means we have 15 $10 bills. And so if we look at our situation just to double check, it says we had $390 worth of those bills. If I multiply 10 times 15, that's $150. And then 20 times 12, that gives me 300 and what is that? 20 times 12? No, 240. So 240 and 150 adds up to 390. Perfect. And there's three more $10 bills than there are $20 bills. It asks us to find the number of each type. Another strategy or thing that I would encourage you to use is write down what we know and what those variables stand for. It makes life a lot easier once we figure out what X is in order to answer the question. Mixture problems can be pretty interesting, fun stuff. Draw some pictures, label the stuff that you have, and you can calculate all kinds of fun stuff. I hope this video was helpful. Keep working hard on your math. You can do it.